Hi, this is Merlin. Today I'm just gonna talk about Valorant today. So the main problem was I was trying to like take the video early, but I was not able to do it. So let's see. So today the topic is hold on. Let's say the topic is the fat cycle. If you look at the experience, wait, not this part. Hold on. Yep. So if you have experience of some kind of making operating system, you were able to learn, like for example, corner thing. But the first thing you have to learn about the fat cycle. Basically, I mean if I more say about fat cycle is basically instructions. Fat cycle. So what do I mean by that? In the operating system, there is a process thing. So you can simulate working on it concurrently. But the thing is that if it is like this really hardware level, like without operating system, you just basically using assembly. There's no such a thing as like reading whole of the program language and execute by same time. In this low level, the CPU or the processor can read just one instruction by per time. What I mean per time is just like it only can read one instructions in one moment. And so example, there's a bunch of instructions. Instruction 1, instruction 2, instruction 3, instruction 4. The CPU is basically can only execute the first part, and then it goes next part. And this is kind of the question might be the occurred because okay, the CPU is doing the instruction 1, but what about 1 to 2, 3, 4? So 2, 3, 4 has to be stored in some way. So that is why we put the 2, 3, 4 into memory. Let's see, like this part. 2. Like, let's see, this is just a bunch of memory. And 2, 3, 4 just gonna be stored in this part and this part and this part. Okay, but after you compare with the instruction cycle, and it has to go look at the next instruction, and it has to read memory, and it goes like 2, 3, 4, and that's kind of really process of it. After executing the instruction, it has to fetch the next instruction from the memory and decode and execute, and that's kind of really simplified explanation of that cycle. But you really have to understand this sort of the logic is being used in it's really hard. So to look again, you have to understand what is register. So the register could divide into two part, general, special. General purpose of register, special purpose of register. So basically, general, what the general do, it just stores some kind of the simple value of it. But special purpose of it, there's a special purpose. Example, code segment register. There's a lot of things. Code segment. No, not this part. Instruction pointer register or PC program counter register. So this kind of example of instruction pointer program counter register, because the CPU using this PC register, the program counter register, as a value to get the memory offsets of it. So basically the equation is PC times 16 in the real mode. I'm talking about the real mode plus the code segment register. So that's the formula to get the fixed car memory address. And after and that's where we process all this, but in x86 there's some kind of big diagram. I forgot it was like BIU and EU. And the BIU in the BIU EU, so in the EU there's two things gonna be here: decode and execute. In the BIU there's gonna be fetch. So they're using they're doing communication via the bus, and there's a queue, prefetch queue, which it's just for the sending, or it's just to send the instructions. Just I1, I2, because the queue is just like FIFO, I3. So when I1 is being there, it's gonna go to the EU, and it goes to decode process and skip process. And after it's done, it goes here. After it's gone, it goes here. So that's how we kind of simplify the process of it in x86 architecture. So this is it. Have a nice day. See you next time. Bye bye.